So this is just Alex right now. However, this can change. This is 20% of your overall grade. So 20% of your overall grade is at 41%. That's not too great. It means that you have no way of actually getting an A in the class, even if you got an A on everything else. In Alex, your pi is a certain percent of your grade, and then your homework a certain percent of your grade, and your external assignments are a certain percent of your Alex grade. So if you are really low on external assignments, I think I dropped like 3 external assignments too. In your grade book, there should be a line through it if it's dropped. So I did. I extended the homework. The pi hasn't been extended. You have to email me and get, and then I'll email you back saying it's extended. For some, I could go in. It would just take a lot of time to go in and do it for every single person. So one step, you got to email me that, and it will be extended. But the homework is extended, and they're quick retakes. So if you miss 3 problems out of 5, you don't have to take the 5 over again. Just go in and do those 3, and it'll update your grade. This was downloaded this morning. So this is where everyone's at this point in the semester. 3/4 of the semester done. This is not looking too good. There's hope though, because you can get this up to 100%. It is possible you can reach 100% by the time you take the final exam. And I think by doing that, it's going to help you prepare for the final exam as well. So I want to see you guys succeed in the course, and sometimes I feel I'm not for sure if it's getting across the barrier. I don't know what the barrier is for each individual person, but I'm trying to do everything in my power to get you over the hump, to get you to where you need to be, especially in that final exam, because it'll replace your lowest test score. So I'm going to go ahead and pass out. It's the exact same test you took in class, right here. And I want you guys to bring this back to class on Wednesday. And I probably won't give you back your graded test until Friday. And what I'll do is kind of average the 2 grades together. So you got a 0 on in-class test and 100 on the take-home, you'll have a 50. 75, 80 will be somewhere between 75 and 80. But I think it's really good practice too, because a lot of these are going to be on the final exam. A lot of them we did in class, very similar to the ones in class. And I'm going to go over just some highlights. I'm going to pass this out to you guys. I don't want you to work on it in class. 30. I'm going to Math 130, this is section 4. Okay. The first page was good. There wasn't a lot of things that went wrong. First page. The last 2 pages are pretty terrible. There are multiple ways to do some of these problems, and that's perfectly fine. I was surprised on number 7, since you guys all had your calculator, that some of you missed those. You can plug them in your calculator and change a base and get your answer.
We do LN and B.
There's multiple ways you can do it. So look, and so you guys have access to my lectures where we talked about things. We've done examples of all these. You also have your notes. So if you're like, oh, this is the notes from 4.2 or 4.3, I can go and watch that lecture and find that part where she talked about this and then answer those parts. Number 9, some of you had the right answer with no work, and I'm not sure. Show your work. So I'm going to take off points on the take-home part if you don't show your work. So if you get the right answer, that's great. I just want to see why.
I did the weird way.
I want to see it.
I just guessed and checked.
Yeah.
On my calculator.
Yeah. So I want to see the proper way instead of guess and check.
It was weird. I didn't know if it was right. So
yeah. So yeah, now you don't know if it's right either because I'm not giving your test back. So if it says simplify as much as possible, you need to simplify it. Number 11, some of you got really, really close, but you try to make this a 4 instead of making this 2 squared. So it was, again, difficult to grade. The 30 points was for, some of you questioned, 30 points for number 11. Number 11 has multiple parts, so each one of them is worth 6 points. Yes, I saw some of you circled out like, wait a minute. Yeah, but that's for all the parts of number 11. Yeah. Yeah. So, and that's, I mean, it's a good gauge to kind of see, but it's 30 points for number 11, and there's multiple parts there. Don't forget to solve for X and not U. Some of you had solved for U and said, done, bam. But no, I want X, not U, which is really close. But some of you guys missed points for that. And then we did examples of every single one of these in class, maybe the exact ones. So I want you guys to spend some time with really understanding if any of these showed up on the final exam, you would have no problem doing them. And then it's also going to help your test grade, because in the end, that's at this point what most of you are concerned with, right? Not necessarily knowing this and nailing it on the final is what grade you have on this exam 3. So I'm going to average your exam 3 in class and your take-home exam 3 grade for your exam 3 grade. And I'll put that in Blackboard, but it won't be until Friday. Debated about giving back your guys' test, but I wrote on a lot of them, like, here's the right way to do it. And then halfway through grading it, I came up with this idea. So I don't want to give them back yet, but I can tell you your overall score at the end of class if you want to know, okay, you got a 78 or you got a 23. You can know that at the end of class. But I'm not going to let you take the test. All right, so chapter 4 will be 25% of your final grade. Or your final exam questions. 25% will come from chapter 4. Today, we're going to continue on with chapter 7. And I will pass out the notes. And chapter 7 only has 3 sections. Let's see if I can find the notes. And we're going to start with the eclipse. Chapter 7. Go ahead and pass out the notes for chapter 7. Okay, guys, can you guys put away the take-home test and actually take it home and pay attention to chapter 7? Or I can just give you another in-class test. Students get a little disconnected from chapter 7 material. Some of it you've seen before. There's not a lot of application. It's more memorizing like formulas. It assumes you know the formula for a triangle, which was in chapter 2. We didn't cover it though. Or the formula for a circle. X squared plus y squared equals maybe h squared. Okay, this is a circled center at 0, 0 with radius. Your book uses R. With radius R. You guys have some of you guys are familiar with that. We're going to do the same thing with these shapes in chapter 7. We're going to talk about ellipse, hyperbola, and a parabola. And we're going to then take those and we're going to shift them in the X direction. We're going to shift them in the Y direction, just like we did with the graphs later on. And there's going to be some things that we want to highlight. The origin. So a lot of times we'll want to find the origin of the graph or the origin of the figure. We'll talk about the origin. A lot of times we look at the basic formula and it's at 0, 0, but it's possible we can shift it H and K, where H is shifted in the X direction and K is shifted in the right direction. It's the exact same idea as, you know, taking the graph and shifting the X 3 units to the left or 3 units to the right, and the graph the function 3 units up or 3 units down. So this is a basic eclipse. An eclipse comes from taking a conic section, take these conic sections and we slice them. If we slice it parallel, we get a circle. If we slice it at some angle, we get an eclipse. If we slice it perpendicular, we get a hyperbola. And then if we slice it at some angle, we get a parabola. So this is 7.1, 7.2, and 7.3. Those are the 3 sections we're going to cover in Chapter 7. So our next test will only have 3 sections on it. It will be 100 points, 15% of your overall grade. And on the final, 25% of the final will be just 3 sections from Chapter 7. Right? These questions can get, there's a lot of calculations in them sometimes. Some of the things they want to calculate. The definition of an ellipse is a set of all points x, y in a plane such that the sum of the distance between x and y and 2 fixed points is at a constant. The fixed points are called focal points or focus points of the ellipse. Right? So if I take the focus points of the ellipse and I find D1 and D2, D1 is the distance from this point to the x, and D2 would be the distance from this point to the y. It's going to be constant no matter any xy on the curve. A lot of times this is made by a string. If you take a cork board and you can put, 2 points on the cork board and then take a string and trace it, you get an ellipse. That string is that constant distance, D1 plus D2. So the formula, we can have an ellipse with the major axis being the x-axis or ellipse with the major axis being the y-axis. And it turns out, here's the formulas. They look very similar, right? This is the major x-axis, so this is the major on the y-axis. And it turns out here, A is larger than B. So highlight this, A. So depending on if it is the eclipse on the major axis or the major axis is x or the major axis is y, depends on which one has the higher number in the denominator, right? Because they're not going to be A, B. It's going to be some numbers. The center on these cases are both 0, 0. The focal point is C0 and minus C0. And it happens to be on both of these. You ask yourself, what is C? C is always A squared minus B squared, which would make sense because A is always larger than B. So if you take the larger number squared minus the smaller number squared, you get C squared. So to calculate C, you take the square root of that. And that should make sense with the Pythagorean theorem. The vertices, I'll ask you for the vertices. The vertices are endpoints on the major axis. So they're going to either be A0 minus A0 or 0A, 0 minus A, which makes sense because if it is on the x-axis, is the major axis, I have something that looks like this. So this point, my x values are going to be A minus A. My y values are going to be 0. But if the major axis is on the y-axis, I have something like this, and my x values are 0, and my y values are A and minus A. Half the battle on this is identifying the shape you have, picking out the A, picking out the B, finding the C, and then labeling it as focus points vertices. Vertices where it crosses the major axis. So the vertices can be on the x-axis or they can be on the y-axis. So here's kind of the summary of what's going on here. Corresponding endpoints on the minor axis correspond to the b value, which is the smaller value, right? So it can be on the minor axis here or the minor axis here. So this is the equation for this circle, and this is the equation for this circle. Remember, A is larger than B. So if A is under the x squared component, then your ellipse is on the major axis is the x-axis, and the distance between 0, 0 is A and minus A, right? And this is B and minus B, which makes sense because if y is 0, you can solve for x squared. You can solve for x as x equals the square root of a squared, which is plus or minus a, right? Y equals 0 is the x-axis. If x equals 0, you can solve for the intercepts of the y-axis by setting x equal to 0, all right? So you get here plus or minus a in this way. Do you guys see that? So a lot of students try to kind of memorize what's going on, what's A, what's B, what's C, and try to force it. But if you think about, let's let y equal 0. What would x possibly be? If x is 0, what's y possibly be? You get your endpoints on your major axis and your minor axis. You can get your center, and you can get your focus points. You have everything you need to kind of graph this. So this is kind of what it's trying to tell you here. This is the standard form for an ellipse. If I set y equal to 0, I find the intercepts of my x-axis. If I set x equal to 0, I find the intercepts of my y-axis. Here, if A is larger than B, that tells me my major axis is my x-axis. You guys starting to see some of this? So let's look at the first problem. Given the formula, graph the ellipse and identify the center, vertices, and the focal point. So is it going to be major axis x-axis or major axis y-axis? X, right? I could rewrite this as x squared over 4 squared plus y squared over 3 squared equals 1. So what is my vertices, or where do I intercept the x-axis at? X equals minus 4 and x equals 4, right? Which makes sense because that's where y equals 0. So this would be minus 4, 0. This would be 4, 0. Where do I intercept the y-axis at? Yes, so 0, 3, and 0, minus 3. And do you guys see how I can find that by looking here, plugging in y equals 0? I get x squared equals 4 squared. So y equals 0 is the x-axis, so I get plus or minus 4. If I solve for x squared, plus I take the square root of that, I get plus or minus. I can do the same thing and set x equals to 0, that's the y-axis, when x is 0, and I get plus or minus 3. You can see this corresponds to the x-axis, this corresponds to the y-axis, this point here, this point here. So we've answered 2 of the questions, the vertices, the major axis vertices and the endpoints on the minor axis. The center in this case is 0, 0 because there's no shift in x and y. And eventually we're going to add shifts. And then if the shifts, we have to be very careful because this tells us A is 4 and this tells us A is 4. So when our center is 0, 0, it's really easy to find the endpoints, right? Because I know it's already 4 units, so it's minus 4, 4. But if our center is 3, 2, then I have to say 4 units to the left and 4 units to the right. Those are my endpoints. And we'll eventually get there, but right now we're just looking at center 0, 0. The last thing to calculate is the focal points. And the focal points are always on the major axis. So it's going to be somewhere here. So I know my y component is 0. You guys remember the focal points here have to deal with c squared equals a squared minus b squared. C is the point on the major axis, a distance from the center, right? So this distance here is C in both directions. So C squared ends up being 16 minus 9, which is what? 7? So C is the square root of 7. Square root of 7 to the left and square root of 7 to the right. The plus or minus, that's where that comes from. Question.
Are you wanting us to simplify that further, or is that it?
Square root of 7 is fine. So my focal point here is actually going to be a point, right? So this would be minus square root of 7, 0, and this would be plus square root of 7, 0. So you guys see that? Now I could graph this. It's not extremely interesting, graphing. More so, you're going to be asked to identify the center, the vertices, and the focal point, and anything else you could possibly ask. So a lot of your answers are points. So the center here is 0, 0. The vertices, a lot of times this will be broken down into major axis, minor axis. But vertices is always the major axis. So in this case, minus 4, 0, and 4, 0. Even though they didn't specifically ask for the minor axis vertices, we would know that to be 0, 3, and 0, minus 3. The focal point, square root of 7, 0, and minus square root of 7, 0. So do you guys kind of see it from that basic shape? Finding A and B, what corresponds as A and B? Finding C, what C is, and putting it all together. Let's look at the next example. What is going to be the major axis here? X. What are my endpoints on my major axis? Yeah, right. So be very careful because it will ask for points. So it's 3, 0 and minus 3, 0, right? But yeah, you're along the same lines. What are the endpoints on the minor axis? Right. Very good. Plus or minus 2, but then we want to also put that into points. The x is 0 and the y is plus or minus 2, right? Do you guys see that from the picture? Some of you are there, some of you. So one of the things you always want to rewrite it in the form x squared over a squared plus y squared over b squared equals 1. So here a plays the role of 3 and b plays the role of 2. So if I go here, I know my major axis is the x-axis because the number under the x is the largest. So I know this plus or minus 3. Minus 3 to 0 and 3 to 0. The minor axis, plus or minus 2, 0, 2, and 0, minus 2. Drawing it looks like this. The center on these have been the same at 0, 0. So the only thing I need to find is the focal point. So I know it's going to be on my x-axis because that's my major axis. So I need to calculate C. This is C, and C squared is a squared minus b squared. So C is 9 minus 4, which is 5. So C is the square root of 5. So my focal point, this point, and this point is minus square root of 5, 0, and 0, square root of 5. Nope, sorry, square root of 5, 0. Square root of 5, 0. I know it's on the x-axis, so I know my y is 0. It's going to come in handy drawing this because when my center changes, let's say I move my center up 2 units. So all my y's are going to be 2.
How do you get that? I don't understand how you get that. 0, 2.
This 0, 2? Because the 0, 2 corresponds to, if x was 0, what would y be? Y squared would equal 4, right?
Yeah.
So y would equal plus or minus 2. So that's a good way to think about it. You can also think about the 4 is under the y-axis. So the endpoints or your vertices on your minor axis are going to be 0 plus or minus b, really, if you memorize it as b. But you kind of want to avoid doing that, thinking of this is a and this is b. The only thing that comes in handy is to find the vertice. The vertice is always c units from the center. So right now our center's been at 0, 0. So it's been relatively easy to find, right? You got to be really careful when that center moves. So we end up with answering the question, is the center 0, 0? The vertices is at 3, 0, and at minus 3, 0. The minor endpoints are at 0, 2, and 0, minus 2. The focal point is at square root of 5, 0, and minus square root of 5, 0. You guys see that? Know what the distance between the center and the minor axis, the center and the major axis, and the center and the focal point. We can present this a little different way, and you have to convert it to that standard form. So how would I go about converting this to the standard form? The standard form is when it equals 1. So I need to divide through by 225, right? So I have 25x squared plus 9y squared equals 1 if I divide both these by 225. If I do that, I end up with x squared over 9 plus y squared over 25 equals 1. So sometimes it might not present in standard form. The first step you need to do is get it in standard form. So what's the major axis here? The y, and the minor is the x, right? So that tells you your focus points are going to be on your y-axis. So what is the endpoints on the minor or the major axis? Yeah, right. So I got to be a little careful because it's actually 0, 5, and 0, minus 5, right? Plus or minus 5 is where that comes from. Here, I'm 5 units from the center, but I'm 5 units up and 5 units down. Question. Here, 25 divided by 225 is 1/9. And 9 over 225 is 1/25. This fraction, if you put it in your calculator, is 1/9. And if you put this one in your calculator, you get 1/25. That's a good question. You have to be able to convert it to standard form. Once it's in standard form, minor axis, what's the endpoint? Right? Everyone's going to see plus or minus 3, but I have to be careful because it's actually minus 3, 0, and 3, 0, right? The x is the plus or minus 3, the y is 0. And this always helps to draw the focal point, because solving for c is not difficult, but plugging it in the right axis is what's important. So my focus points are always on your major axis. So my focus points are going to be on my y-axis, meaning my x component 0. So what would c be? C squared is always a squared minus b squared. It's always the larger one minus the smallest one, right? So what does it end up being? 16, the square root of 16 is 4, right? So it means it's 4 units up and 4 units down from that center. So this point would be 0, 4, and this point would be 0, minus 4. Drawing it is not too interesting. If I would have stretched it out a little bit more, this is 5 units and this is 3, which doesn't look that way, but let's see if I can fix that. Question? Yeah, so on answering these, I'm going to have you write the center, and you'll put 0, 0. And I'll have you write the vertices, and you'll write 5, 0, and minus 5, 0. They'll actually be points. The picture part comes in really, really handy when you're at h, k. When I take that 0, 0 and move it up and over.
How come on the last one, like those 2 dots that we solved for D, they were on the X, but now it's on the Y?
Very good question. Because the major axis is always where your focal points are. Here, the major axis is the X because the larger number is under the X. Here, the major axis is the Y because that larger number is under the Y. But yeah, so making those connections is going to be really important because that's going to hold true when we translate these curves x, y, or in this case, hk. If I move the x center and the y center to some hk, you're still going to have the major axis is going to be parallel to the x-axis, or it's going to be parallel to the y-axis. So your center point is very important. I take the center point and I move it up 4 and down 4. So my x component doesn't change, only the y component, and the y component changes by a length of c.
So that's
Yeah, so then
write it down and do 0.
it would be 0, 4, 0, minus 4. So yeah, if we continue on here, we have the center, we have the vertices, minor axis endpoints. In this case, would be 3, 0, minus 3, 0. The focal points are going to be 0, 4, and 0, minus 4. And it's on the y-axis. The y-axis, the x is 0. The x is 0. So you guys, I want you guys to work on the next one, kind of on your own. The first step you do is you convert it to standard form. How do you convert it to standard form? Divide by 900. So you want the coefficient in front of the x and the coefficient in front of the y to be 1. So you write it as a fraction.
Okay. So, great, you have to use H. That is telling me where is that on the graph? Yeah, so what would it point to? Yes. Endpoint. We're kind of taking, right now, we're kind of taking for granted that center is 0, 0. No, in this case it is because the standard, there's no shifting in the X or the Y.
Eventually, if you turn your page, we're going to look at this, and this is along the same setup, except I'm shifting it X and Y. In this case, H and K. I'm shifting so my center is now at H comma K. But everything else is going to play out the same way. And yeah, pre-calculus is college algebra and put together. So yeah, you do this. Yeah, it is. So if you're taking a pre-calculus in high school, it's same thing. Now, a lot of this is just kind of knowing the general form and then seeing how your function is being translated. Knowing what A is, what B is, what C is, but then we're going to be shifting it all over space by H and K. Yeah, you have to be careful when to use A and when to use A squared. So most of you guys have gotten groups. No, I'm not gonna on your graph. I'm gonna look at your point. The graph is very important though to make it click, to help it make sense. And you guys were doing a lot better job than I was kind of looking at this. So what do we get? X squared. Draw, maybe? Depends. Okay. So what did you get? X squared divided by 900 divided by 25. 36 plus y squared over 100 equals 1. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. X squared over 36 plus y squared over 100 equals 1. In this case, the center is 0, 0. We get x is 0 here, y is 10. X is 0 down here, y is minus 10. Here, x is 6, 0. Minus 6, 0. Whoa, sorry. Minus 6 is on the left. Minus 6, 0. 6, 0, right? So this presents us with a focal point on the y-axis, right? So I know my focal point is going to be on the y-axis. Sometimes I'll just put it in here. Just to remind myself, once I calculate C, I'm looking at C on the y-axis. Okay, so 0, 0. C squared is A squared minus B squared. So C squared is 100 minus 36. So c squared equals 64. So c would be 8. It's actually plus or minus 8, and that tells me I go up 8 and down 8, right? So in this case, it's 0, 8, and 0, minus 8. Question? It might be like square root of 7. Might, and eventually, this point is going to eventually change, and it might be 3, 4. So this might be 3 plus the square root of 7. Or 3. Sometimes it does come out with square roots. Most of them are nice, but sometimes I randomly generate them and they come out ugly. It would just be, you could just do an approximate, yeah. You could say, you could take the square root of 7 in your calculator, which is, see, and you could add that to, and then roughly know where it is, yeah. Mm-hmm. No, yeah. I want it to visually look like this is a major axis, but if you have all your points, it's fine, yeah. And what's going to be really important when we shift it, you're comfortable graphing it to know, here, this is my major axis. So I'm going up 8 units. If I shift this point 3 units to the right, the 3 is going to stay the same. So all these points should have x equals 3. The y is the only thing that's changing. And the same thing in the minor axis. The only interesting thing in the minor axis is the endpoint. Everything else happens on the major axis. Why is major? So the next thing we're going to look at is when we shift it. We have too much time to go through an example, but I want, instead of memorizing something like this, all you have to do is think about it. Once you calculate C, you need to go either up C or to the right C, down C or to the left C. So K is going to stay the same, right? Your Y component, if my major axis is the x-axis, right? My major axis in this case is the x-axis. This is my center at HK, H, comma, K. If I move here to the right or the left, K does not change, right? If I just kind of come up here, this is my major axis. If I move to the left or the right, K does not change, right? This is H, comma, K. This is going to be H plus, in this case, H minus C. H minus C, comma, K. And this is going to be H plus C, comma, K. You guys see that? This is the C units we talked about before, the focal point. If this is if the major axis is shifted up 4, that's fine. K stays the same. If X is your major axis, that means your Y component stays the same. If Y is your major axis, X component stays the same. So looking at it, they should all be the same. That's why kind of graphing it, you can see, looking at all these points, they're all 0. Looking at all these points, well, that's not the major axis, sorry. Looking at all these points, the major axis, all the X components are the same. Looking at the minor axis, all the Y components are the same, 0, 0, 0. The same is going to hold true when you shift it, HK. Another important thing to make sure is H and K are positive, right? So if I have X minus K, I shift that K unit. But if I have X plus K, I actually shift it minus K units. The center. So if we just look at an example real quick. Here, where's the center of this problem? Three minus 2, right? 3 minus 2, right? In the form X minus K, and this would be X minus a minus 2. So this is K, and this is H. Put minus 3 in there. And this is K. So my center is always at, switch them, H and K, right? That form X minus H and Y minus K. H here is a positive 3, and Y here is a minus 2. You can look at it and say, what do I mean for my x to be 0? What do I need for my y to be 0? The center is at that point, x comma y. All right, so I'm running out of time. We will pick up here on Wednesday. I'll also take your take-home test that I gave you. I also posted on Blackboard, so if you're not in class, you can print that off, or if you lose it, you can print that off and bring it in on Wednesday.
Do you have it memorized?
I did.
Why